functions. So I'm going to demonstrate the way how the JVM makes the dot class to be platform independent. In the earlier video, we saw the detailed workflow understanding of how the JVM interprets the dot class and make sure that it gets executed in the respective operating system. So right now the slide what you're viewing, it's the actual workflow process that happens behind the scene of JVM. Now I straight away take you to the demonstration where we will compile the source code that's got created in the Mac operating system, and we will compile them in the Mac operating system and we execute it in the Mac operating system. Next is I'm going to take you to the Windows operating system where I'm going to copy the dot class file that we will create in the Mac operating system to the Windows operating system, and we are going to execute the dot class there in the Windows operating system and experience whether the dot class will get executed successfully or not. Because the dot class that is generated in Mac operating system, we should confirm if it's getting executed in the Windows operating system, so that we can confirm that Java is a platform independent technology, right? And who does the job of making sure that Java is platform independent is your JVM. So let's straight away get into the demonstration. So right now we already have the greeting.java. Right now I'm on the Mac operating system. So what you're viewing right now is a Mac operating system. And here I've written a piece of code. You can view that here. This is the piece of snippet that we used in the earlier demos as well. I'm using the same file, greeting.java, and we don't have the dot class here. Right now we only have the source code. We don't have the bytecode format. So I'm going to generate the bytecode. So let's first look at the working directory so that we will confirm if we are in the right directory or not. Yes, of course we are on the right directory where the greeting.java is present. Now from here we can issue the command of javac, right? For compilation, we are supposed to use javac space greeting.java and hit enter, and this would produce the dot class file. So here it should populate the dot class file. Let's confirm if it's getting generated or not. So once the dot class is generated, we'll be able to execute the dot class and see if we are able to get the desired output in the Mac operating system. The next thing that we are going to do is we are going to copy the dot class file from the Mac to the Windows operating system, because the dot class that is actually getting generated is in the Mac operating system. So the same dot class file should be taken to the Windows operating system and ensure the dot class is getting executed there or not. Okay, so I guess it got generated. You can have a look at it. So right now we have this dot class got generated out of this .java file, and that's what that process was done by the compiler. We have the Javac compiler here who produced this dot class file. But make sure that right now I'm running on the Mac operating system. So the Mac operating system actually produced this dot class file. So I reconfirm that the Mac operating system, in the Mac operating system, we developed the greeting.java source code and handed over to the compiler who is there in the Mac operating system, who helped us in producing the dot class file, right? And the dot class file got generated successfully without any compilation error. Now the next step that we need to do here is we need to execute that dot class file, the bytecode file, and see if it's getting executed in the Mac operating system. So for that, I'm going to use Java space greeting. I guess I already gave you this explanation that while you're executing the bytecode, never use the extension. Just say Java command space the file name of the bytecode, greeting, and hit enter. This will produce the output by executing that greeting file. Now what exactly happens? Let's quickly recall. It initiates the JRE, and in the JRE the class loader loads the dot class file and hands it over to the bytecode verifier, and the bytecode verifier is pushing that bytecode once the originality of the bytecode is verified to the JVM, and the JVM will interpret it and produce the output according to the Mac operating system. It produces the format of machine code according to the Mac operating system, and it happened. So if you see, we got the output. So what exactly would have happened by now is this command is helping us in invoking the JVM as well in turn, and the JVM interpreted this dot class to the machine code, and the output of the execution is seen here. So finally the system is taking the machine code as an input for it, and it executes the instruction and then gets the output for us. Okay, so all these things happen in the Mac operating system. Now the same dot class file alone I'm going to carry. I'm not going to carry the dot Java. Okay, dot Java is your source, so don't carry the dot Java file. Instead, we need to carry the dot class file into our Windows operating system, and there we need to find out if we are able to execute this dot class file or not directly without compiling again. So the dot class which got generated in the Mac, we are going to test if it's going to get executed in the Windows operating system. Okay, let's see that. So the first thing, I'm just going to push them into my OneDrive. So because I do have a virtual machine, but I will be unable to drag and drop them directly right now. That is a small challenge that I'm facing. So I can show you my Windows operating system which is currently running. It's the virtual machine. I guess this demo I've already shown in the installation part of the JDK. So the same operating system is what is up and running in a virtual environment. So now what I have to do is just copy them and put it into the OneDrive. So let's take the dot class file first, and let's put it into the OneDrive. Okay, so let's drag and drop them into this OneDrive. I hope. Actually, this dot class file is going to reside inside this OneDrive so that we can take a copy of this in the Windows operating system. So let's see if this is getting copied. Hopefully there should be no challenge. So let's go back to our Windows operating system, and here again I have kept my OneDrive opened. We have to see if that file is getting copied into that specific location. I have some challenge. So the machine is a little slow because I'm also parallelly running the virtual operating system, so that's why the copy operation is also a little slow. But hopefully let's see if it's getting copied successfully. So I guess it already got copied. So yeah, so we got this greeting dot class here, right? So this greeting dot class, we need to copy them into our Windows operating system. So this is our Windows operating system. So let's take a copy of this down here so that we'll be able to execute this dot class alone straight away and see if it's getting executed. That's the main theme of this video demonstration, right? So let's see if we can copy this. It's taking a little bit of time. That's okay. Let's stay patient. Let's keep this dot class file into our Windows machine. Now this can be dragged and dropped. So here we have the greeting dot class which got downloaded in the Windows machine. So this file was actually taken from the Mac operating system. So please get highlighted. I just wanted to emphasize this again and again. The reason of this demonstration is to make you people understand that the file that we have created in the Mac operating system, the dot class, the bytecode file, which we have created in the Mac operating system, is getting transmitted into the Windows operating system, just the dot class file. And we are going to see whether the dot class file is getting executed straight into the Windows operating system without carrying the source file. Okay, so that's something, an interesting part here. So let's paste this. Once it is dropped into this location, I'm already up and running with the command prompt, probably the one which you might be using in the Windows operating system. And right now the Windows operating system is, the command prompt is having the directory mapped to this location, and we need to check if this greeting.class file is available. Please make a note of it. There is no .java file. The source code is not there, right? Source code is missing. I didn't copy the source code. We don't need the source code. That's the intention of this demonstration. We don't need the source code. Just transfer the .class file straight into the Windows operating system from the Mac operating system. The actual source code was generated in the Mac operating system, which is now shifted into the Windows operating system. You don't need the source code. Okay, fine. So now let's see if we are able to view the .class file here. Yes, of course, in this location we have the .class file. Only the .class file is present, right? We don't have the .java. I stress out again and again. So now we can go ahead and execute. So how do we execute here in the Windows? Execution command stays same across all operating systems. So you don't need to think of having a different command for Windows operating system, right? It's going to be the same. So let's go ahead and say Java. I'm not using Java-C in Windows right now. Make a note of it. I'm not using the compiler here because we have a compiled code which got compiled in the Mac operating system is now transferred to the Windows operating system. So let's say greeting. And as I said, we should not use the extension. Just use Java space greeting and hit enter. So the JRE is triggered. The .class is getting loaded with the help of a class loader, and the class loader will hand it over to the bytecode verifier, and the bytecode verifier is verifying the bytecode and hand it over to the JVM, and the JVM is interpreting the code to the Windows operating system. So now you got the output, right? But actually the .class file was generated in the Mac operating system, the Macintosh operating system, but the same .class file is now executed on the Windows operating system, right? So how it happened? It's because the .class file is the intermediate file between your compilation and the execution. So your JVM right now is for Windows. Okay, the JVM right now we have is for Windows, and the Windows JVM knows how to interpret this .class file and convert or interpret that .class or the bytecode to the mission code. But this time the JVM, which is of Windows, is going to interpret to the mission code of Windows type. Okay, Windows type of mission code is going to be generated and it got executed. So can we take this .class straight into the Linux operating system? Yes, of course. You can carry this straight into the Linux operating system, and there you will be having a Linux based JVM, and that JVM knows pretty well how this greeting.class can be interpreted. So the same way, vice versa also we can do. We can create a .class file in the Windows operating system, and we can shift them into the Mac operating system, and there you can just execute the .class file. So you can see a portability comes into the picture. So this particular bytecode file is highly portable, right? So the meaning of portable is you can carry this dot class in any operating system, but still the dot class can get executed with the help of that respective JVM installed in that machine. Because JVM is the sole responsible person to interpret your bytecode and make sure that the bytecode smoothly executes in that corresponding operating system by generating that operating system specific machine code, and so the JVM becomes platform dependent. Before we compiled and we executed in the Mac operating system, but this time it's on the Windows operating system. So JVM is very tightened to the platform specific, but makes your Java technology to be called as a platform independent, because as a developer I develop the code in the Mac operating system, but still it is able to get executed in the Windows, because the intermediate file is the dot class file, the bytecode file, and that's the reason that we call the Java as a platform independent technology. And also the Java language is an interpreted language, because JVM comes into the picture to interpret your code. Which code it will interpret? The bytecode, right? Hope you got the complete understanding of how this JVM practically works. I've shown the demo of the Mac generated bytecode to get executed in the Windows environment, and vice versa also we can try out. So you can just see if you could come up with some virtual operating system. You can try this demo by just creating a dot class in Windows and then try it out in Linux. And the same way you can create one dot class in Linux and copy that Linux in, dot class into the Windows operating system and see if that dot class gets executed. But what you need in the respective operating system is the JVM. Okay, that operating system specific JVM is required. JVM is Java Virtual Machine. Okay, it acts like an operating system, that specific operating system, to understand the bytecode, interpret the bytecode to the machine code of that corresponding operating system, right? So this is the complete clarity of JVM. In the next video, we'll see more interesting topics which are lined up. So thank you so much for your time. We'll catch up in the next video.